gonna multiply by sine 5x. So for this one, we're only deriving this part, which is basically e to the power of negative 4x. And then now we add, as we can see above here. Now I'm gonna keep the e to the minus 4x constant and derive the sine 5x. Let me go to the next page. So now I'm gonna have minus e to the 4x. Now we are deriving sine 5x. So the same thing applies. Sine of something on its own is a function, but the 5x inside here is also a function. So we'll apply the same chain rule here. So when we derive sine of something, we know it should be cos of the same thing. The thing is 5x. And then we'll multiply by the derivative of the inner function, which is 5x. So essentially our answer is minus 4 e to the minus 4x sine 5x plus 5e to the minus 4x cos 5x. So this is the answer they were expecting from us. Is there anyone who has a question? So if there's a step which doesn't make sense or which you need clarity on, just open your mic and tell me that you don't understand, because there's no time to understand. It is from now. One day is not a lot. So is there anyone who has a question with regards to this? Right, okay, cool. So I'm gonna assume you are all fine. So let's move.
Sergio, there's a question in the chat.
Yep,
Someone is asking, someone is asking why 5x?
Why 5x?
Yes. I don't know why exactly. So if they can unmute themselves, maybe that would be good.
The 5x is coming for...
Okay, you can go ahead.
Yeah, I'm saying, do you see that we had sine of 5x? So I said, usually you will have a function. That's what I was writing here. You'll have a function which is f, which is a function of g. In this case, sine of something on its own is a function. And the thing inside, which is 5x, it's also a function. Meaning when we derive now, we'll find the derivative of sine. You know the derivative of sine is its cos, but the angle is 5x. But we will multiply by the derivative of the angle, which is 5x. So that's what I was saying by chain rule here. I was like, you should find the derivative of the bigger function, which is f. Then multiply by the derivative of the inner function. In our case, the inner function here was 5x. And the derivative of 5x is simply going to be 1. That's what I was doing here. And even here, with the minus 4x, e to the power of something, e to the power of, let me say p. This is a function, e to the power of something. But p on its own is a function, So which means when we derive, I'll find the derivative of e to the power of something the usual way. Then I'm going to multiply by the derivative of the inner function, which is p. I don't know if that answers the question. So please unmute if it doesn't make sense. Can I easily follow if you talk?
Okay, they've responded that they've understood. You can continue.
Okay, cool. So let's go to the next question. Let's see. What is the next question? Find the derivative of. So I'm looking for limit questions. Okay, so
Okay.
yeah.
Someone sent a question in the WhatsApp group. Maybe you may start by that one. So I'm gonna read it to you, right?
Mm.
So it says function of t is equals to 1 over t to the power of 4, then open bracket, cosec t minus 1. So 1 over t to the power of 4, then you open brackets. Inside the brackets, it's cosec t, then minus 1.
Minus 1. So here they were saying we should find the derivative.
Yes.
Okay, cool. So let me quickly rewrite this. So more nicely, it looks like this. Cosec t minus 1 divided by t to the 4. So obviously we can see here that, so instead of having a product, we have some division here. Division. Yep. So which means instead of using the product rule, we should use the quotient rule. Do you still remember that? So just a quick reminder, if you have y is u over v, when we derive y, the quotient rule simply says, let me see, we'll derive u first and then keep v constant. I hope I'm not forgetting this, and then minus v dash and keep u constant, and then I think you divide by v squared. Am I getting it right? Yep. Yeah, this is okay. So this is your quotient rule. So just remember this rule. And so your u and v are just functions of x. So in this case, if you can look at our function here, our u is simply cosec t minus 1, and our v is t to the 4. So if we use this formula above, our derivative of f will be, we need to derive u first. Here's our u. Here's our formula. It says we should derive u and then multiply by v. And our v is simply the denominator. So if you differentiate cosec t, what is going to be the answer? Anyone can shout. So if you derive cosec t, the answer you get is negative cot t times cosec t. And then the derivative of 1 is obviously 0. And then we minus now. Now we are going to derive our v. And guess what? Our v is simply t to the power of 4. So that's going to be 4t to the power of 3. And then again, we simply multiply by our u, which was cosec t minus 1, divided by, we should divide by v squared. And our v, in this case, it's t to the 4. So t to the 4 squared is simply going to be t to the 8. So this is the answer they were expecting from you. Then you can do the grouping here and simplifying simpler. This is the answer they were expecting you to get. I hope this answers the question. Right. So I'm going to note this as 2. Okay, so let's move. There's a problem of limits. So I'm going to call this 3. So the problem we have is the limit of the cube root of x plus 8 minus 2 all over x. And they are saying this should be evaluated as x approaches 0. So if you try to sub in the 0 here, the answer you will get is simply going to be 0 over 0. So it doesn't work. And if you remember, this is what we call an indeterminate form. Determinate, let me see. Let's give it a try. Indeterminate form. So all what we need to do for this one is we need to try and rationalize this by simply doing this. So I have cube root of x plus 8 minus 2 over x. I'm going to multiply by cube root of x plus 8 plus 2. Cube root x plus, that shouldn't be too long, cube root of x plus 8 plus 2. So if we do the maths there, the cube root is gonna, let me see, 1 over 3 plus 1 over 3. This is gonna be worse. Okay, this is not a square root. So what do you think we should do for this problem? It was gonna be easier if it was a square root, but it is not, because essentially what I have is 1 over 3 times 1 over 3. Yeah, okay. This is not gonna work. So what do you think we should do here? Okay, yeah. Okay, let me do this and then I'm gonna explain afterwards. So that's gonna give me x plus 8. No, it's gonna complicate things. So what do you think we should do here? And the quick question is, have you guys done L'Hopital's rule? So one of you can reply. Have you guys done L'Hopital's rule?
Yes, they're responding, yes. Guys, please, so the person who is presenting, they are in full, they're in full screen mode, so they cannot see messages. So I suggest that for the sake of engagement, please just unmute yourself and speak. You're very welcome to just
Okay.
unmute yourself and speak. We're not in class; these are not lecturers, so don't be worried. Just unmute yourself and then speak. Okay.
Okay, cool. So if they've done L'Hopital's rule, it becomes way, way, way simple. So just a quick reminder, you only use L'Hopital's rule if you get an indeterminate form. See what I wrote here. And an indeterminate form, it's either when you have a 0 over 0 or infinity over infinity. And then you can use your L'Hopital's rule. Because doing it the way I was attempting to do it now, it was gonna be rough, but it is doable. So L'Hopital's rule says if we get an indeterminate form, 0 over 0 or infinity over infinity, we try again to evaluate the limit. But the only difference now is we will derive the numerator as a whole. We'll derive the numerator and derive also the denominator and try again. So if we do exactly that, the numerator here is going to be 1 over 3 multiplied by x plus 8 to the power of, I'm going to have 1 over 3 minus 1. It's 3 over 3. That's minus 2 over 3. And my 2 is going to be 0. And then I'm going to divide by the derivative of x. Remember, we said we find the derivative of the numerator. Derive the numerator on its own. And then it's going to equate to this. And then after doing so, derive the denominator. And then put the answer here, which is going to be 1. Right. So let's see. So this works out to be 1 over 3 multiplied by, it's going to be multiplied by the cube root of x plus 8 all squared. And then now we can sub our 0. So if you put in 0 here, you can see we won't have any issues. So let's try and put a 0 there. We put in a 0 there, we'll have 1 over 3 times 1 over the cube root of, that's going to be 8 squared. And the answer there will be 1 over 3, let me see, times the cube root of 8 is 2, and then we square that, we get a 4 in the denominator. So the answer is 1 over 12. I hope I didn't make any mistake. Is there anyone who has a question? I think I was going to ask a question here. I hope. Do we all agree that when you derive this, you are going to get what you see here? Is there anyone who disagrees?
Yes, there's a disagreement in the chat. Can you please mute yourself? Can you please unmute yourself just so that you can be able to speak, and we can engage.
Okay, so let me go to the next page and see if I didn't make any mistake. So we have the cube root of x plus 8. So we can all agree that this is x plus 8 to the power of 1 over 3. Right? And then if we do the derivative of this, we know we should take the 1 over 3 power down, right, and multiply by x plus 8. And then there in the exponent, we should subtract a 1. And if you look carefully, my 1, I can simply write it as 3 over 3. Right, so if you look carefully, this is going to be 1 over 3 x plus 8 to the power of negative 2 over 3. Did I flip this on the other side? Let's see. Nope, I didn't flip this. So I hope I didn't make any mistake here, but I know I did not. So I think we can move. The person needs to look carefully into this. And yeah, I hope they will get this. So essentially all what we did is we use this rule. X to the n, when you derive it, simply nx n minus 1. That's all, nothing new. So if you go to the previous page, after deriving, we get this expression. And then when we derive the x in the denominator, here, we get a 1. And then this expression becomes this, and then we substitute our 0 here. And finally, this is what we get. So I'm not sure if the person who was saying they do not agree is still in disagreement. I'm not sure if they are, but I hope they are not. So let's move to the next question.
See here, just before you move, I just wanted to just make sure that we are on the same page. Samkela and William, do you have any objections? And where do you think could be the mistake, if there is? And if you are satisfied, then we can move on. Just indicate, you can type in the chat, then we can move on. Please go ahead. You can actually you can unmute yourselves, and then we can proceed. I see someone was asking. Yes.
So I wanted to ask, given the question, it says when x approaches 0, is it possible to do the same question but saying x approaches infinity, or is it not possible in this question?
CK?
Yeah.
Did you hear the question?
So the question was, can I do the same when they say x approaches infinity?
Yeah, so is
Yes,
it always going to be like x approaches 0 or x approaches a
Or
constant?
x can approach any value. It can approach a 5, it can approach infinity. So if x approaches infinity, you don't necessarily substitute here. So if x approaches infinity, this is going to be 0. Just think about it. So let's say x approaches infinity. And the expression we have here is 1/3 times 1 over the cube root of x plus 8. So do you see that the bigger we make x to be, the bigger the denominator. And the bigger the denominator, the smaller the overall answer. Because we have 1 over a really big number, and 1 over a big number is approaching 0. So essentially, we're evaluating this as x approaches infinity, your answer will approach 0. Just think of 1 over a really big number. 1 over 1,000 is close to 0, but 1 over 1 million is closer to 0. But at the end of the day, the bigger the number becomes in the denominator, the more we approach the value which is 0. Not sure if that answers the question.
I know, sir, I did. So thank you.
Okay, cheers. Let me look for
CK?
yes.
So the objections from the chat, they have said that they don't see any mistakes anymore, so we can proceed.
Okay, cheers. So let me take another limit question and see what's going on. So this one should be 5. Hope I'm not losing track. Okay, should be 4. So the limit, the question is the limit as x approaches 4 of 1 plus 2x minus 3 divided by the square root of x minus 2 minus square root 2. So the first thing you should always try to do is just try to sub in the value here. Let's go here and say, okay, cool. Let me put a 4 here on x and let me put a 4 here. Let me see what I get. If we do so, I'm gonna get the square root of 1 plus 4 times 2 is gonna be 8 there, minus 3 over the square root of 4 minus 2. Okay, the square root shouldn't be big. Square root of 4 minus 2 minus square root 2. And if you look carefully here, your answer will be 0 over 0. Because this will be 9 and the final answer from this square root will be a 3. and this will simply be square root 2. So square root 2 minus square root 2 is 0 over 0. And guess what? This is what we wrote in the previous page. In determinate form. So we said when we have an indeterminate form, 0 over 0 or infinity over infinity, all what we'll do is use L'Hopital's rule, because you guys know L'Hopital's rule already, so it's easy. So L'Hopital's rule says, okay, cool, you should try again, but now when you try, make sure you have derived the numerator and make sure you have derived the denominator, and then you try again. If you still get 0 over 0, infinity over infinity, try again. So let's see how this goes. If we derive the square root of 1 plus 2x, so I'm just going to write it as 1 plus 2x to the power of 1 over 2, right? So if I derive the square root of 1 plus 2x, I'm going to get 1 over 2, 1 plus 2x. Then I'm going to minus 1 here, 1 over 2 minus 1. Chain rule, I'm going to multiply by the derivative of what is inside here, which is simply 1 plus 2x. Final answer is going to be 2. And then the derivative of 3 is 0, divided by, we do the same there. So square root of x minus 2, that I'm going to write as x minus 2 to the power of 1 over 2. So if I derive this part, I'm going to have the 1 over 2 coming here, x minus 2, 1 over 2 minus 1. Then multiply by the derivative of what is inside here, which is going to be 1. Okay, cool. So if that's the case, then let us try and write this in a neat form. It's below here. I have the limit as x approaches 4 of okay, so let me write this and then you'll see. Obviously, let me cancel these first. The 1 over 2 and the 1 over 2. They're going to cancel. Then what I have in the numerator is 2, 1 plus 2x to the negative 1 over 2, divided by x minus 2 to the negative 1 over 2. So if you remember your exponential laws, I can simply say this is the same as the limit as x approaches 0 of, I can flip these because of the negative here. This can come here. And because of this negative here, this can come here. Not sure if that makes sense. So let's give it a try and see if it does make sense. Raise this one. So I'm saying this is the same as 2 times x minus 2 to the 1 over 2 divided by x 1 plus 2x to the power of 1 over 2. Yep. So if we do now, try again plugging in the x here and see if we are still going to get 0 over 0, infinity over infinity. So let's see, if we plug in the x in the numerator, we'll get 2 times, oh, this is a 4, not a 0, sorry. This is a 4. We try and plug in the 4 again, it's going to be 4 minus 2 to the power of 1 over 2, divided by, in the denominator, it's going to be 1 plus 4 times 2, that's going to be 8 to the power of 1 over 2. So the answer there, if you look carefully, it's just going to be 2, 2, 1 over 2 divided by 9 to the power of 1 over 2. And remember, 1 over 2 is simply the square root. So we have 2 square root 2 over square root of 9 is 3. So this was supposed to be the final answer. Is there anyone who is lost? Is there anyone who is lost? Okay, cool. I hope we are all clear.
Sisha, there's a message in the chat. So no
Yeah.
wonder you're asking that why are we not using the quotient rule when we are doing derivatives? So yeah, so she's asking why are we not using the quotient rule when doing derivatives? So from the formulation of the L'Hopital's rule, so what we are supposed to do is when we have 0 over 0 or infinity over infinity, we take the derivative. We take the derivative of the top function, then the derivative of the bottom function. We don't. We don't differentiate the function as one function. So if we differentiate the top, differentiate the bottom, not combine them as two. So that's why we're not using what do you call it, the quotient rule, because when you use the quotient rule, you are now basically combining the two. So the idea is when we have 0 over 0 or infinity over infinity, you derive the top function independently, then you derive the bottom function. I hope I've answered you.
Yes. So we are not deriving the entire function. That's why I was making these boxes here. I was like, L'Hopital says if we get 0 over 0 or infinity over infinity, he is saying we should derive the top function separately and then put the answer there and then derive the bottom function also. This is what I did. This expression above, it's the derivative of the top function. The expression below is the derivative of my denominator separately. So that's L'Hopital's rule. You derive the top function. So generally, let me say this. So let's say you have a limit as x approaches a, and the two functions are f of x divided by g of x. So let's say after plugging in a on f and g, you get 0 over 0, or you get infinity over infinity. What we do is L'Hopital says try again, try the limit again as we approach a. But now what you should do is you derive the top function. You divide by the derivative of the bottom function. So he's not saying let's derive, he's not saying this. His rule is not saying this. If he was saying this, then we were allowed to use the quotient rule. But his rule is saying what I wrote here. That derive the top function separately, divide by the derivative of the bottom function. Try plugging in the a again. If you still get 0 over 0 or infinity over infinity, derive again for the second time. So that's what the rule says. I hope that answers the question. I hope it does. Okay, cool. So let's look for, let me go up. Optimization. Let's see here. Okay, cool. So there's another question in the group chat. Find the limit as x approaches infinity. Okay, this is so nice. Okay, so let's look at this one. There's someone who sent this question. So we are finding the limit as x approaches infinity. Infinity is a big number of 5x minus 1 over the square root of, let me see, I think it's 7x plus 1 plus cube root of 2x plus 1. I hope I see this well. Yep. Okay, cool. So we'll do things the way we do. So let's try and put a very big number here. Right. So if we put infinity there, it's going to make this part to be very big, minus 1. The square root of a big number is still a big number. Cool. The big number, infinity, is going to make the square root to be really big. Plus, it's also going to make this one, when we plug in the big number here, it's going to be big. So it's big plus big, still, it's a huge value. So essentially, we have infinity over infinity here. So which means we should now try and see what L'Hopital's is saying. Because guess what? What we have here is an indeterminate form. So meaning I'm going to go now and do what I was doing in the previous page. Derive the numerator. Here's my numerator. And derive the denominator separately. And try putting in the big number again and see what we get. So let's go. The limit as x approaches infinity. If we derive the numerator, 5x minus 1, this is simply 5x minus 1 to the power of 1 over 2. Right, so if we derive that, you'll get 1 over 2 times 5x minus 1, 1 over 2 minus 1, multiplied by, remember, chain rule. Chain rule, I'm going to multiply by the derivative of what is inside. When I derive what is inside, the term which is going to be left is 5. Cool. We divide, and then we apply the same principle in the denominator. X plus 1, 1 over 2 minus 1, and then multiplied by 7. Chain rule again. We are deriving the inner part. 7x plus 1, if we derive, you will get a 7. Cool. And then we come to the next term here, still in the denominator. So we have there the cube root of 2x plus 1, and that is simply 2x plus 1 to the power of 1 over 3. That's what cube root means. So if I derive that, I'm going to have 1 over 3 here. 2x plus 1, 1 over 3 minus 1 in the exponent, and then multiplied by 2, which is the derivative of what is here. So let me quickly try and write this neatly and try again and see if this is going to work. The limit as x approaches infinity over, let me see, so that's 5 over 2 multiplied by 5x minus 1 negative 1 over 2, 7 over 2, 7x plus 1 negative 1 over 2, to x plus 1 negative 2 over 3 here. Okay, cool. So let's see again. How do I write this in a nice way? Nice way, nice way. me see. As we approach infinity. That part, okay, up there I'm gonna have 5 over 2 over, let's separate this. I'm gonna have 5x minus 1, 1 over 2 multiplied by multiplied by 1 over, okay, give me a sec, 7 over 2 divided by 7x plus 2 to the 1 over 2 plus 3 over 2 divided by 2x plus 2 plus 1, 2 over 3. This is how it's gonna look. Looks messy, really messy. But let's try again and see what happens. So if we plug in infinity here, now use green. We plug in infinity here. This as a whole is gonna be a really big number, right? But guess what? It's just the same as 5 over 2 divided by a really big number. I'm sure we can agree this is going to approach 0. So if you take 5 over 2 and you divide it by a big number, it's going to approach 0. Right. So essentially the answer for this question, I believe it should be, wait a sec, we don't have any addition here. It should be a 0 because look at these ones. So if we put in infinity here, this term as a whole is going to be big. But it's divided, we are dividing that term by 7 over 2. So meaning what is going to come here out of this term is going to be a really small number. Think about it, because the denominator is big, the numerator is small. So one small number divided by a big number, we are approaching 0. The same here, if you put in infinity here, the denominator here will be really big. But because we are dividing by this, the overall answer here is going to be really small. Right? So essentially, in the denominator, you now have a really small number plus a small number over 1. That's going to be, the same will give us a really big number as a whole. That big number, you can just call it infinity. But that number doesn't matter because this multiplication here, it makes everything to be 0. I'm not sure if this answers the question, but the answer here is supposed to be a 0. So L'Hopital's role, all it did for us was to make sure we no longer have infinity over infinity, because it's hard to work with that. So if you no longer have infinity over infinity or 0 over 0, you can work out the answer. It's going to be whatever which comes out. So I'm not sure if there's a question on the chat, because I cannot see the chat. So just unmute if it doesn't make sense and I'll try again.
So everything makes sense. I just wanted to ask. So like if they give you infinity or 0, they want the final answer like that. And if they give you a constant, do you have to substitute like you did in the last one? Like does
Yes.
that work?
Yeah, for a constant you can substitute, but for infinity you can substitute, but it really doesn't make sense. You can, but for a constant, substitute directly and see if again you get 0 over 0, infinity over infinity. If you don't get 0 over 0 or infinity over infinity, whatever answer you get is the actual answer.
Okay,
so here I couldn't sub in infinity. So it's more like I was doing it in my head, because I cannot treat infinity as a fixed number. So that's the problem. That's why I cannot substitute infinity. I just know if I plug in infinity there, the entire term in the denominator will be infinity. And then I know 1 over infinity is going to approach 0. I do not necessarily substitute infinity as if it's a defined value.
No, okay, I understand, sir. Thank you.
Okay, yes. I'm looking for a different.
Sorry, sir.
Yes,
Can I ask,
yes,
on
you
the
can.
third step, the one that you wrote with a pink pen,
Which with the what?
a pink pen or purple,
Okay, let me see. Do you mean
it's the
this,
second last step.
the second last step? Oh, you mean here?
Yes.
Yes. What's going on?
Yeah, on the denominator, it's 7 over 2 times 7 plus 1 all raised to minus 1 over 2, and then plus 2 over 3. Isn't it supposed to be 3? Isn't it supposed to be 2 over 3, not 3 over 2?
Yes, I wrote. You are saying, isn't it supposed to be 3 over?
Oh, now I see you corrected it. Okay.
Yes, I wrote 2 over 3. Does it make sense?
I mean the coefficient there.
Oh, the coefficient. Okay, let me see. So times by that. Okay, so it's a minor mistake because here I eventually used 3 over 2. Okay, thanks. Let me see. Yeah,
Okay.
you are right. It's a typical mistake which you can make in the exam, and the lecturer is not going to understand it. He wants all the marks to himself. Okay, cool. So let's look at another question. Did you guys do integration? Because there's a question I got for integration. There's a question I got, and there's a question. Okay, see this one. Let me look for another question quickly, because you guys were the ones who were supposed to be giving me questions. Because I feel like I'll choose the questions which I like. That's weird. Okay. A the numerical coefficient of the 11th term, the binomial expression is expressing the way they copy this question. I cannot read the entire question. Okay, they should send the entire question. Okay, did you guys do integration / I think it's anti-derivatives? There's a question I got. So I'm asking a question. It should be a yes or no. And remember, I cannot see the chat because I need to leave here. I want to see what you are writing.
Yes.
Okay, cool. So let's give it a shot. And please send your questions, because I'm here to answer those questions, not to do questions which I think I like. Okay, cool. So let's look at this integration problem / anti-derivative. This is weird. The person who sent the integration question, they just delete it. Okay, no. Yeah. Okay, yeah, this is the question. So so you were asked to integrate 1 over 1 minus x over the square root of x minus 1 dx. Right, so I'm gonna smile first. And the next question is, did you guys do U substitution? substitution. Have you ever heard of something called U substitution? Right, so in the meantime, while I wait for you to answer the question, I'm gonna factor out a negative out of the integral to make this.
Yes, we did use substitution.
In fact, there's no need for U substitution here. Okay, let's see. X minus 1 dx. So let me write this in a form which will obviously be clear. X minus 1 to the power of 1 divided by x minus 1 to the power of 1 over 2. And you guys are smart. I'm sure you can agree that the answer there is going to be x minus 1 dx. So remember exponential laws. A to the m divided by a to the n, simply a to the m minus n. So that's 1 minus 1 over 2, hence the square root as the final exponent, which is 1 over 2. So let's see. So I'm integrating the square root of 1 x minus 1 dx. This is essentially the integral of x minus 1 to the power of 1 over 2 dx. And I'm just going to use this logic. This is going to be, we add a 1 and we divide by the exponent. That's what I'm going to use there. So if we take this to here now, I'm sure we should agree that the answer is going to be negative x minus 1 to the power of 1 over 2 plus 1 divided by 1 over 2 plus 1. So essentially the answer is negative x minus 1 to the 3 over 2 divided by 3 over 2, and the final plus c. Don't forget c because people are emotional about c. Makes sense why. So the final answer is going to be negative 2 over 3 multiplied by the square root of x minus 1 cubed plus c. Is there anyone who is lost? Is there anyone who is lost? So here we didn't need the u, but you can use the u substitution. So that's nice.
So, is it possible that you could use U substitution? Like show an example.
Yes, sir. So let's see using u substitution. So the negative is out already. So I have x minus 1 over the square root of x minus 1 dx. So I'm going to be like, okay, cool. So I can see this. I can see this here. And also I can see it even here. Okay, so let me make what is common, what I see as common as u. Let me make it u. So I can say u is the same as x minus 1. But now if I want to use u in my expression, if I want to make this u and this to be u, I will now need to have my du instead of dx, because now I'm integrating with respect to u. Okay, cool. So we now need to find the derivative of u here with respect to x.
CK.
Yes.
We cannot see your screen, or I don't know if it's me.
Oh, so you can no longer see my screen.
Yeah.
Everyone, or is it you? It's only you.
Yes, we found.
Okay, so this is so weird.
Can you just So stop presenting first and then you present again.
Yeah, I think Google is kicking out people. It's over an hour. Can you see?
Yes, not really. People are still in. So my suggestion is you are still sharing. So first, I mean, so I'm saying first stop sharing, then go to Google. So what I suggest is, can you leave the meeting, then come back again through, I mean, what do you call it? I mean, through the Gmail app, and then try to share again.
Yeah, I think you should create another meeting. On my side, it is saying people have left. Whoever is leaving is leaving. All of them.
No, but
So
people are still in the meeting.
okay, so let me leave and join again.
Yeah.
Okay, can you now see the screen?
Yes, we can see.
This is obvious. Looks like Google is working with the lecturers to get people out. Okay, cool. So if we derive the right, what we are gonna get is 1. And remember, we are now trying to make everything here to be in terms of u, meaning even the dx here is now supposed to be in terms of u, which means I should solve for dx and make it to be in terms of u. So if I multiply both sides, I'm gonna have du is equal to dx. So meaning wherever I see dx, I can now put du. And where I see x minus 1, I can now put u. So if we do such, on the denominator we'll have u, on is the numerator. And then here you'll have also u, and then you'll have du. And then we know that u over square root u is simply going to be square root u du. And when we integrate the square root of something, we know it's simply going to be u to the power of 1 over 2 plus 1 divided by, missing a negative here, 1 over 2 plus 1. And the answer there is simply negative u to the 3 over 2 over 3 over 2 here, plus c, obviously, plus c. This is going to be 2 over 3 minus u square root of u cubed plus c. And we can now subtract our u. So we know before we even did this magic, we had u as x minus 1 cubed plus c. So this is the same answer as what we got on the previous page. Let's see. Does it answer the question to the gentleman who asked?
Oh, yes, it does. Thank you.
Yes. Okay, so let me look at there's someone who said something about matrices. Okay, let's see what's going on there. Solve the matrix equation AX is equal to B. Okay, so let's see matrices, and hopefully it will make sense. Okay, so the question was solve the matrix equation. And what we are solving is AX is equal to B. And guess what? Your A is simply 3 minus 1 minus 6, minus 3. And your x is simply x1 and x2. And your b is simply 7 and minus 9. Right. So they are saying I should solve for ax times b. So if I write that in matrix form, simply 3 minus 1 minus 6 minus 3. Here comes the x, x1, x2. And they're saying this should be equal to b, and b is 7 minus 9. Right. And obviously they come and say find x1 and x2. Okay, cool. So this is all nice and easy. Then the question should be, did you guys do Cramer's rule? Did you guys do Cramer's rule?
The answer is yes.
Oh, nice. So Cramer's rule is saying, so if you look carefully here, so this is the x1 row column effect. This is the x1 column and this is the x2 column. Kind of. Okay, so let's see. Let's solve for x1 first. So x1 is gonna be, Cramer's rule says if you are looking for x1, okay, so before I go to x1, let me quickly remind you of something. Quickly, the determinant of a matrix. So the determinant of a matrix is simply a 2 by 2. So let's look at a 2 by 2 matrix. You have A1 here, A2, A3, A4, because essentially for Cramer's rule, you use your determinants to solve this thing. The determinant of this matrix is going to be A1 times A4 minus A3 times right. So this simply becomes A1, A4 minus A2, A3. Right. So this is what I wanted to say. And then if you go and solve for x1, x1 is simply going to be the matrix. This matrix. So this is the x1 row. So we'll cancel this row. And then take what is after the equal sign, put it here. So essentially, my matrix is going to look like, I'm going to take the 7 from the right and the minus 9. And then the minus 1 and the minus 3 are going to be there. And these straight lines, they simply mean we are going to take the determinant. And then I'm going to divide by the determinant of my original matrix, this one here. And that matrix is simply 3 minus 6 minus 1 minus 3. Right, so if you follow the same logic I presented above here, you will realize that in the numerator, you will have 7 multiplied by negative 3 minus negative 9 multiplied by negative 1 divided by, we will have 3 multiplied by negative 3 minus negative 6 times negative 1. And the answer here, let me see, that's negative 21. That's going to be negative 9. So that's negative 30 divided by Let's see the denominator, that's -9. That's -6. That's -15. So the final answer here will be 2. So meaning essentially my x1 is 2. Are we still together? Okay, so let me copy this one. And then look carefully at how I'm gonna get x2 first. This is really simple when you use Cramer's rule. So let's go back to this page. Yeah. Paste here. Here. Yes. We still have people here. Silence is worrying. Okay, cool. So let's look at this one. We said this is the x1 row. Now we are looking for x2. And guess what? I'm gonna say, okay, so this is the x2 column. So I'm gonna cancel it out and then replace it with the column which is after the matrix. So essentially my x2 is gonna be 3 minus 6. I'm gonna have a 7 here minus 9. This is all divided by the original matrix here. It's like I did on the previous page, which is 3 minus 6 minus 1 minus 3. So following the same logic, this times this, I'm getting 3 times 9, it's what, -27. Minus 27 minus 6 times 7 divided by this matrix, that's -9 minus 6 times -1. So let's see. So we have -27 here. 6 times 7. It is 6 plus 7. I think it's 42. So that's positive 42. So 36 plus 6, 42, yes. And then divided by -9. -9 minus plus -6. That's negative. And what is 42 minus 27? 42 minus 27. Okay, so it gives me 15. So I have 15 over -15. And the answer which I'm getting is a good -1. So x2 is a good -1. Is there anyone who doesn't understand this Cramer's rule thing? Because you can literally solve any matrix which you are probably going to be given tomorrow using these. So you can solve any question. So let me quickly repeat what you do when you're using Cramer's rule. I'm going to use a general example to brush off, because if you see a matrix tomorrow, you can literally use Cramer's rule. So Cramer's rule. So essentially, when you have a matrix, or when you have an expression, let's say ax plus by, cx plus dy, this is equal to, let's say this is E, and let's say this is F. And they are saying we should solve for x and y. This you can write as in matrix form, and write it as AB, CD, and then you can have x, y, and on the other side of the equal sign, you have E and F. That's what we had previously. So when you now have these in these forms, all what you do is you'll be like, okay, so here I'm dealing with the x's, and here I'm dealing with the y's. Cool. So if I am looking for x, what I am gonna do is I'm gonna come to the row where there is x, where I'm pointing here, and remove this and substitute it with what is after the equal sign. So put this bracket, and then you'll have E and F, and then the B will still be there, and the D will still be there. And then you will divide by the original matrix, but its determinant, which is A, B, C, D. And then the determinant, remember, the determinant of a 2 by 2 matrix. Quickly, if you have A, B, C, D, the determinant, B, C, D, the determinant is simply AD minus BC. Right. So that's how you get your X. And then let's come to the Y now. Y. I'm gonna go to my original matrix and be like, okay, so this column, we are dealing with Y somehow. So I'm looking for Y. So I'm gonna remove whatever which is here, replace it with what is after the equal sign. Okay, cool. I go there, I'm like, okay, I have AC, but instead of BD, I'm gonna have EF. Then I'm gonna divide it by the original matrix, its determinant, which is AB, CD. Then these straight lines, they simply mean the determinant. And the determinant, you find it by doing this, multiplied by that. I hope this is clear. So that's what I wanted to say when it comes to solving your matrices. You can literally use your Cramer's rule and chow any matrix which you can come across using Cramer's rule. Okay, cool. So let me look for another interesting question. Solve for x if you are given this. Okay, so let me, right, so this question was sent latest. Okay, so cool. So let's do this easy question and then go and solve for x. 7. So the question was e to the m, I hope, multiplied by e to the x times e, and all this to the power of 3 dx. So this is not hard at all, because we are smart and we know from high school that ab to the power of m is simply a to the power of m, b to the power of m. And we also know that a to the power of m to the power of n is the same as a to the power of m times n. So this is nothing deep. And also we know that a to the power of n times a to the power of m, same basis, they multiply, we add exponents as m. We have a to the n divided by a to the m, a to the n minus m. So this is nothing new. So let's deal with this integral, which is trying to look fancy. So I'm going to have e to the m. M is obviously constant, so it doesn't matter. So let's distribute this 3 here, inside here, here, here. So if I do so, I'm going to have e to the power of 3x times e to the power of 3 dx. And then what I can do here, this is a constant. These are constants. So I can factor them out and simply say these are e to the n plus 3. And factor that out. So what I did before factoring out is I multiplied them. You add the exponents. So inside I'm left with only the function of x. because I'm looking for the integral with respect to x. So whatever which is not in terms of x, it can go outside, right? And if I do my integral there, it should be 3 to the x. Now we do the inverse of what we were doing in chain rule. I'm going to derive by the derivative of 3 to the x plus c. So essentially this becomes e to the m plus 3 multiplied by e to the 3x divided by 3 plus c. So the final answer here is supposed to be e to the 3x plus m plus 3 over 3 plus c. I hope this answers the question that was sent. It does. Okay, cool. Solve for x. Solve for x. Let me, I saw such a question somewhere. Yeah. Okay, there we go. So just stop me if there's something which doesn't make sense. So I'm gonna send this to the WhatsApp group after the meeting. So Sticks should drop the link of the WhatsApp group on the chat so you can all join. Because I'm gonna send a PDF of this after the session. So let's see what's going on. Okay, looks like there's someone who's unmuted. What's up? Do you have a question? Okay. So let's do this one. Solve for x. This is obviously a trick. So the question was 1 plus cos t, let's see, cot squared t. Okay, this is x, I like t, times 1 minus c cos squared x. This should be equal to tan x over 3. Okay, cool. This is not a nice one. Okay, so the first thing I'm gonna do is I'm gonna do something which I hope you will understand why I'm doing it. Let's see. Okay. So I'm gonna have 1 plus cot is simply cos squared x over sine squared x, cot squared. And then I'm multiplying by 1 minus. So I need us to remember something. Remember, who is calling me? Okay, so remember from metric that 1 minus, okay, that sine squared x plus cos squared x is 1. So this implies that actually 1 minus cos squared x is sine x squared from here. So me, what I'm gonna do is, instead of writing 1 minus cos squared x, I know that if I take the cos this side, it becomes a negative, I'm left with the sine. So I'm gonna leave sine squared x here. And this is gonna be equal to tan x over 3. Okay, cool. So if we multiply here, this is gonna cancel with this. And here we will have sine squared x. So let me write this next line. So we will have sine squared x plus cos squared x, because the signs will cancel. And this is going to be equal to tan x over 3. But wow, guess what? This is a good one. You know this from metric, it is simple stuff. So this is a 1. So which means essentially what I have is simply a1 is equal to tan x over 3, still there, and this essentially means tan x is equal to 3. And then you can take it from here. So I'm not sure if you guys are allowed to use calculators. Are you allowed? Are you guys allowed? So I can't see the chat member.
They are saying yes.
Oh, nice. So, so from here it's up to the calculator to give you the answer. It's so nice. Okay, cool. So let me move to the next question. I think I'm no longer seeing any questions. Answer this one. Answer this one. Okay, this is last one which I got. Okay.
Sir. Sir.
Yes, I can hear you. Shoot.
Can we go back to the last question, please?
Yep.
The previous question.
You mean the one before this?
No, this one.
Okay.
So on the third step.
Yes.
Yeah. So the sine squared x cancelled each other, right?
Yep.
Then what we are going to be left with is 1 plus cos squared x.
No.
Okay.
So remember, this is gonna remember your foil. It's gonna multiply here and multiply there. Foil.
Oh, foil, yeah. Okay, now I get it. I get it.
Multiplying the entire bracket. Mm-hmm.
Yeah.
Are
Thank you.
you?
Yeah.
Okay, nice. Let's go to this question 9. So 9, they were saying we have 4 cos squared x plus 3 plus 3. This is the same as, oh, this is gonna make me sweat. It's the same as the square root of 3 cos x. Okay, so this one is not an obvious one, to be honest. But what I'm gonna do is, okay, let me see what I'm gonna do here. So I'm gonna try and act smart. So I'm gonna have 4 times the square root of 3 times the square root of cos x, right? So I'm sure we can all agree this is still the same as this. I didn't do any rocket science here. It's okay, all nice, cool. So what I'm gonna do is I'm not comfortable working with this. I'm not comfortable. So rather I'm gonna call that square root k. I'm gonna deal with the k later. I'm gonna call it k. Right. So I'm gonna come here and be like, okay, so I have k as the square root of cos x. And here I have cos squared x, and it should be written in terms of k. And then I'm gonna have k is only, and this is gonna be easy to do. So I'm gonna square my k. And when I square the k, let me see, I get cos x. But I'm looking for cos x squared. So meaning I should square the k again. It's going to be k to the 4. That's going to be cos squared x. So let me see if I plug in these, how it's going to turn out. So I don't know how I should approach this. I'm thinking in real time. So let's see how it goes. If it doesn't work, then I'm going to think of something else, which is essentially what you are going to do during your exam. You think of something and then you realize it doesn't work, you quickly pull back and rethink. So let's give it a shot. So I have k to the 4 plus 3, and I have 4 square root 3 times k. This is not gonna be nice. Okay, rather let me make this to be simpler. Squared squared. Then that is going to be, because I'm avoiding squaring both sides. It's essentially going to keep it simple. Okay, cool. So let me pause for a second here and come the side. And what I'm going to do this side is I'm going to square the left and the right to remove that square root. So let's see, let me start here. I'm going to come back to my solution. So I'm going to have 4 cos squared x plus 3 all squared. This is 4 square root of 3 cos x all squared. So if I square the left, I'm going to have 4 cos that plus 4 times that. That's 12 times 2, that's 24. 24 cos squared x. Okay, nice. And then plus, that's going to be 9. And then I'm going to have 16 times 3 cos of x. So this doesn't even make it to be better. But let me try it out. Okay, so how would you guys go about solving this one? Because I have 2 expressions. It's this one and this one. So if there's anyone who has a different approach, just shout. And let's see what we get. Anyone has a different approach, just make some noise and let's see how it turns out.
Sir,
Yes, sir. Yep.
I'm not sure if this is going to work, but I think we should take the 4 square root of 3 cos x into the other side, and then it becomes negative, and then we expand the square root and solve. That's what I think. I'm not sure if it's gonna work.
Can you please
Thank you.
repeat?
Okay, what I'm saying is, the equation is 4 cos squared x plus 3 equal to 4 square root of 3 cos x. And then we take the 4 square root of 3 cos x into the other side, and it becomes negative. And then we expand the square root, and then we solve.
Okay, so let me see.
As in like 4 square root of 3 times cos x to the power 1 over 2.
Okay, I think I see what you are saying. Hopefully everyone does. Okay, so it's something like, okay, this is so interesting. So let me see what we had here. This is so interesting. So we have 4 cos squared x plus 3. This is the same as 4 square root 3 square root cos x. Okay, so what this gentleman is saying is take this to that side. So if you do so, look at how it looks like. It's going to be 4 cos squared x minus 4 square root of 3 times cos x plus 3. So if you look carefully, we actually have the form of x minus y. See, x minus y squared. This is simply x squared minus 2xy plus y squared. So this is the form I see. Right, and guess what? All what that means is this was initially 2 cos x minus square root 3 whole squared equal to 0. So if you expand this, you will come back to this. So I'm not sure if this is what the gent was saying, but this is what I took out when I'm taking this part to the other side. Right, so obviously for this expression to be 0, what is inside is what must be 0. So basically 2 cos x minus.
Second, when you expand the expression that you have written, 2 cos x minus square root of 3, are we going to be able to get square root of cos x in the middle?
Okay, wait, let me see. Yeah, we are good. Square root of x. No, we are not. Okay, you have a point. Okay, so let me listen to what the gentleman was saying. So I was like, okay, I see the middle term is 2 times the other one. Okay, so from here, what do you think we should do? So anyone can shout. We are trying to think together here. So anyone?
So Seke, what I thought, would be the direction to the answer is to do the substitution first, and then try to solve for k, and then go back to substitute for the cosine of x.
Okay, so you mean what I did here, which I was like, let me pause this for now.
So it's a matter of choosing which one is easier to solve for k, whether to substitute the one for 4k to the power 4 plus 3 is 4 square root of 3k, or the one at the bottom to substitute k.
Okay, so let's see which one is the easier one, because the problem, in fact, all of them are problems. So 4k to the 4 minus 4 square root 3 k plus 3. So I'm gonna need at least one factor for me to solve this. I'm gonna need a k which can make this entire expression to be 0. So That needs some thinking. It needs some thinking. That one needs some thinking. See. Three. Mm-hmm. Okay, let me think of some. One, it's 4 plus 24 minus 6 times 13. 8. 1, 6 times. So is there anyone who got the answer? Let's see, plus 4, plus 4, plus 9. Anyone who is getting the answer, is getting the answer, is getting the answer. Because this question is easy if you can remove the square root, or if you can put a cos where there is cos squared. So you know when a question is hard, usually and to assume there's a mistake. Yeah, okay, cool. So I think we can come back to this question later. Let me check if there's another question. If there isn't, then we'll try and think of this question. Okay, yes, now this makes sense. Thanks. So apparently the real question, thanks to the person who sent me this, the square root is only under the 3. So this makes all what I was writing this side to be right. I can't write this anymore. So remove the square root under the cos. This becomes exactly what I was saying, which is 2 cos x minus the square root of 3.
So the person who sent us the question sent us a question that's wrong, because I mean we were going up and down for a question that's wrong.
Yeah. So obviously we get 2 cos x is square root 3 here, cos x square root 3 over 2. This is something pi over 6. Pi over 3. That's 1, 2 square root 3. So let's see. That. So essentially x is pi. Why am I using pi's? It was in degrees there. Sorry. You guys are using degrees. So this is 30. Let me see the range of the answers. This is 30. Yeah.
When you asked them last time, they said they're allowed to use the calculator, right?
Yes. Oh, they can simply use the calculator from here. No need. Is that what you were saying?
What I was saying, because I remember last time when you asked that are they allowed to then just punch it the calculator, I think they said yes. So if that's the case, then they'll just punch it the calculator and get the answer.
Yeah, but the answer, they should be careful. They said x must be between 150 Okay, I'm writing it the other way around. 150 and 350. So the x you will get here is, let me see, you'll get x is 30. And then you know your quadrants. The next positive value, of course, is in this quadrant. So essentially, your x is simply 360 minus 30. The answer they are looking for is 330 degrees, which is within this range. Yeah, this is your reference angle, remember. Okay, cool. So I was about to sweat. So let's
Someone
see.
is asking a question. Tabiso
About-
is saying, how do you use the calculator to solve the question? So the way you solve Tabiso is, when you have arrived at cos x is equal to square root of 3 over 2, then you take your calculator, then you punch a cos of square root of 3 over 2, then it should give you 30 degrees.
Yeah. Okay, cool. So if there's no question, I'm gonna pause here. I am not.
Tabiso, are you answered? Can you just type yes or no so that I know that you are satisfied, please?
Determine the height figures of the gold cylinder, which is the minimum particle travels. Are they still here? Okay, so I'm gonna take the last question if there are none, which is about binomial expansion. So let's look at what is going on. So it's gonna be 9. Here it's binomial expansion. So the question was, we were given -2 times, let's see, y minus 3 over 2x cubed to the power of 10. Okay, and then they are asking us the numerical coefficient of the 11th term. Okay, so they are saying they are looking for the coefficient of the 11th term. Okay, cool. This is nice. So I'm just gonna give you a quick reminder on binomial expansion, right? So if you have, so I'm just gonna say NP, binomial expansion. So if you have a plus b to the power of n, you can expand this by taking the summation, right, to n from k is 0 from k is 0, n factorial over n minus k factorial times k factorial. Let me write these terms different. And you will have a to the power of n minus k times b to the k. B to the k. Okay, so let's see. So the 11th term, let's see, the 11th term, that's when k is gonna be 11. So that's when k is gonna be 11. That's the 11th term. And guess what? our n from our expression, we can see that our n is 10. Our n is 10. So meaning the coefficient of the 11th term is gonna be, let's see, what is it gonna be? So let's look at this first, and then we'll come back and look at this. So I'm gonna have n factorial, which is 10 factorial, divided by, let me see, 11 term. Let me go back to that question. I foresee trouble here. Where is that question? K cannot be 11. Let me see what is the I here. Binomial expansion. Where is that question now? Okay, there we go. Okay, yeah, see. Okay, so let's get something right. Let me remove page 11. Let me go back. Okay, so I want to expand this manually for these 3 terms so you can see what's going on. Okay, so let us try and expand that thing, minus 2y minus 3 over 2x squared to the 10. So the first term is gonna be, let me see, n is 10 factorial over 10 minus 0 factorial times 0 factorial multiplied by my a is y, so I have y to the power of n, which is 10 minus k, which is 0, times my b, which is minus over 2x3 to the power of 0. And then I'm gonna do the same for k is 2. Expand, expand, and for k is 3. So I'm trying to understand how am I 10 is the middle 10. I'm trying to get something here. Tapiwa, do you still remember your binomial expansion? There's one thing I'm missing. Are you still there? Am I still sharing my screen? We have people here.
CK, yes, you are still visible.
Okay, yeah. So I was checking if you still remember your binomial expansion. Okay, 0. Okay, nice. So the 11th term, so think with me. The 11th term is gonna be at k is 10. Okay, so think with me here. So in our case, our n is 10, right? So from 0 to 10, that's 11 terms. So meaning at k is 10, that will be our 11 term. Not sure if that makes sense. Term, yeah. Because from 0 to 10, we have 11 numbers. So at k, at 10, this will be the 11th number because we are starting counting from 0. So which means our k is 10 is actually what is going to give us our 11th term. Because look, at k is 0, we get our first term. And then I'm going to make k is 1, sum again, that's our second term. K is 2, that's our third term. K is 10, that's our 11th term. So I'm not sure if that makes sense. So k should be 10. So if we do that, let me copy this and go to the next page. Copy. Hopefully it makes sense why the 11th term is at k is 10, because we are starting counting from k is 0. So when you get to number 10, you have counted 11 times. Hope that makes sense. Okay, nice. So we have figured out that actually our k should be 10 for the 11th term. And then we come here, we are like, okay, so let's look at this part only. So we have 10 factorial divided by 10 minus 10 factorial times 10 factorial, and then multiplied by, so let's see, our a is y, so we are gonna have 10, which is n, minus 10, which is k, multiplied by our b, I think it's negative 3 over 2x cubed. Yes, negative 3 over 2x cubed. And this is raised to the power of k, which is 10. So this and this are going to cancel. This is 1. This is 1. So essentially what we have is simply y to the power of 0 multiplied by negative 3 over 2 to the power of 10 multiplied by x to the power of 30. So essentially the numeric coefficient of this is going to be 1. So the numeric coefficient of the 11th term is simply going to be, you can make this 3 over 2 because the power is given to the power of 10. This is what I'm getting. I'm not sure if this is the correct answer. I hope it is. Is there anyone who has a question? Yeah, if there's no one who has a question.
Sir,
Yes.
I have a question. Why didn't we expand the brackets by multiplying by -2?
What do you mean by negative 2?
The equation is -2 into y minus 3
Oh,
over 2
mean
x to the
negative
power.
2.
Yeah.
Oh, rough. So it wasn't part of, it wasn't inside the bracket, so I forgot. It's supposed to multiply here. Does it make sense? You see this expression deals with what is inside the bracket. So if you put a d here, the d is still gonna be there. So it's gonna multiply whatever answer which is gonna come. So that's why I'm putting the -2 now here. I don't know, does it make sense? It doesn't.
Yes, it does. It does make sense.
Yeah, so I missed that -2, which was gonna make them to mark me wrong. So even here, I'm supposed to have my -2. Yeah, thanks. Right, so if there's no
CK, there's an objection in the chat. Taviseng is saying that he's getting 3 to the power of 10, not 3 over 2 to the power of 10.
Okay, Ntabiseng is saying they are getting 3 to the power of 10. There's no division by 2.
Yes, they're saying there's no demand.
Okay, cool. So my question is, what did they do to this two? Because look at our expression, it's A plus B. So essentially, if you look carefully, your A is Y and your B is negative 3 over 2x to the power of 3. So what did they do to that 2?
Tabiso,
I'm curious.
Tabiso, we are waiting for your response. You can type, but the best is you can unmute yourself so that we can engage and see where is the difference.
Hello, sir.
Yes, sir,
Oh, sir, can you hear me?
I can.
Yes, me, I did, I actually cancelled, yeah, like where you wrote negative 3 over 2x cubed all to the power 0. Is it 0 or 10 there, sir? I think it should be 10 there, sir.
Okay, it's 20. Yes, thanks. My mistake. Yeah.
Yeah,
Then,
there it's there.
then what you do, good sir?
What I did,
Um,
so see my mistake I did,
this one.
I cancelled the 2's there. That's my mistake. I can see now.
Yeah, because there's a power here, good sir. So you cannot do such.
Yeah, I had to account for it. Now I see it will be 2 to the power 9 instead. So the answer will be negative.
Yeah, so if you wanna complicate life, your answer can be 3 to the power 10. Looking at the way you wanna write the answer, it's gonna be 3 to the power of 10 divided by 2 to the power of 9. Does it make sense?
Yes, I see now.
Yes, sir,
Thank you.
it does.
See my mistake. So
Okay, no problem. Do not make such a mistake Monday. I hope. Okay, cool. So I think this question is done if there are no other disagreements. Right, so if there's no further question, I think we can call it a day and move. And then if you have questions, you can send them on the WhatsApp group, and then we'll try to respond as soon as we can. Because it's like some of you do not have questions, but if you go now and practice, I'm sure there's a question which is going to come up. So have a look at your type questions and come with them and send them in the group. Then we'll try and respond as soon as we can. So let me do this in the meantime. There's no question. And then forward this to the WhatsApp group. Tapi, what did you drop the link to the WhatsApp group on the chat?
I dropped it before. I hope that it's still there in the chat. Let me just drop it again, just for the sake of those who might not have the link, so that they can be able to get the link. Just give me a second to do that.
Okay, nice. So I'm gonna wait for a question for and then if there's no question, we can call it a day, and then you can send the question on the WhatsApp group.
Okay, see, let me paste the link in the group. Let me paste the link on the chat. So So here's the link for the WhatsApp group. Just to give the last words. Thank you very much to everyone that have come to this meeting. I hope that it was helpful to you, and it was a pleasure for us being with you and discussing together. We hope that you will be able to maneuver your test on Monday. We wish you all the best, and we offer personal tutoring, private tutoring. So to those who will be interested in getting tutoring from us in any subject, especially maths and physics, you can reach out to us. You can reach out to us through our Facebook page, or you can email us at this email that I'm typing here. You can also reach out to us via WhatsApp through the WhatsApp group. You can be able to see our phone numbers. You can just send us your message. You can inbox any of the admin numbers that are there. You'll find them in the group. So we thank you, everyone who have come to this meeting, and thank you very much to Sike for having us today in this meeting. Thank you to everyone who have participated, and thank you everyone to those who are listening.
When are they writing physics? I think we are going to host another session. You guys
Yeah.
do.
I'm sure they are doing physics.
Okay. Not a problem. So yeah, they'll tell us in the group when I will do. Hopefully we'll have a session. So make sure you join the WhatsApp group so you can ask the questions there. So if you can't find the link, just ask one of your classmates, probably in those groups. One of them has the link to the group I'm speaking about. Then we'll talk there. So I think it shares from my side. I'm gonna send this to the group, convert it to a PDF file. Right. So while I do so, let me exit the meeting if there's no question.
Okay, so goodbye everyone. I'm ending the meeting. Bye-bye.
I have a deal for you.
Did you end the recording?